Hey everyone, we're going to continue in 4.2 calculations with percentages, and we're finally going to explain to you what a multiplication factor is. Let's take a look. Let's switch over to the laser pointer as well. It's a bit better to see. Percentage increase. Okay. The price of a 7.25 euros LED light bulb is increased by 16%. You can do this in a long calculation, right? If you say, well, the new price is in that case the old price, 7.25, plus 16% off 7.25. This divided by 100 is 0.16 times 7.25 is 8.41 euros. But again, mathematicians are lazy. We can do this a lot quicker. You can shorten this calculation because you always start at the old price. Then you add the increase. That means that I get the new price, which is 116% per 100. So if I divide this by 100, I get the number 1.16. And believe it or not, I can now calculate the same thing by just doing 1.16 times old. In this case, 7.25 times 1.16. And that's a lot quicker. And not only that, sometimes it really is necessary when we have a long string of calculations. I'll come back to that in a second. This number that we now multiply with is also called the multiplication factor, or in Dutch, the vermenigvuldigingsfactor. You can calculate percentage increases and decreases by just taking 100%, adding the amount you're going to add, and then dividing that number by 100, because you can use your calculator. That should always go correctly, right? So here, 5.3% increase, you multiply with this number. If I have this multiplication factor, I can also figure out what the percentage increase was. I can do this times 100 and then do minus 100, right? You do the opposite of what you do here. Times 100, minus 100. Hey, that's a percentage increase of 13.2%. Same with percentage decrease, only now you do minus. I always start at 100%. In this case, a 12% increase would give me 88%, so divided by 100, and I get 0.88 times odds. That means that decreases always give you a multiplication factor that's smaller than 1, and increases always give you a multiplication factor that's bigger than 1. Okay. Conversely, a multiplication factor of 0.952 gives you a percentage decrease. If you want to calculate this, again, what you can do is do it times 100, then you get 95.2%. And then you started at 100, subtracting, you see that the decrease must be 4.8%. Let's practice this in a few exercises. But before we're going to do that, first, why this is such a cool thing to know about. Because now I can just immediately start multiplying with multiplication factors if I know certain increases have happened over time. And I don't have to do intermediate steps and first calculate and then calculate, etc. For example, if I know I start here with something and in 4 years time it says increased with 40% and then again it increased with 30%, I can just immediately do times 1.4 times 1.3, or even if I first multiply those two, do times 1.82. And then you also see that the percentage increase over time is not 70%. It's 82%. It has to do with the fact that this plus 30% is over something that's already increased by 40%. So plus 40 plus 30% is something different than just doing plus 70% in one go. And if you don't trust me, just give yourself a number, for example 10, do it times 1.7. It's something different than if you're on your calculator, just take 10 and do times 1.4 times 1.3. Okay? And now this is already quicker if you have 2 increases, but let's just say you have 10 increases in a row. Yeah, you don't want to do all the intermediate steps, right? You just want to calculate all the multiplication factors and just do times and times and times and times and times. And then you will have your answer in just a matter of minutes instead of a matter of hours. Watch out with percentage-based calculations like this, because oftentimes they trick people. The price of a product increased in 2021 with 20%. A year later, the price decreased again with 20%. What can you say about the price of the product in 2022? Has this price increased, stayed the same, or has the price decreased? Think about this for a second. And then hopefully, or let's say it like this. I see a lot of people saying, well, the price stays the same, right? I mean, I increase it with 20%, then I subtract 20%, 20 minus 20, 0%. But this is incorrect. The price has decreased, actually. And you can calculate that, because if I have a multiplication factor of 1.2, and then a multiplication factor of 0.8, if I multiply them together, I get a multiplication factor of 0.96, and it's actually a percentage decrease. And it has to do with the fact, and I can actually show you that. Let's write it down for a second. Let's say that I started at 100 euros, and I have a 20% increase. Then I get 100 times 1.2 is 120 euros. But if I'm now going to have a decrease of 20%, and hopefully you see that this 20% is now not applied to 100 but to 120, and that means that because it's applied over a bigger number here, also the decrease is now bigger, and you see indeed that I now end at 96%. Or you could just have, that's what the explainer did immediately. Let's say I had 100 euros. Let's just do this time 1.2 times 0.8, and then you also find 96%. Okay. Oh well, I have already prepared this. I forgot about that. So here's another example, only where the project was 200 euros. Okay, and also with a quicker calculation. Take a look at this. Hopefully you understand why the price has decreased over time. A few examples. In 2015, the Dutch Diving Federation had 16,121 members, or sorry, 16,121 members. A year later, this number has decreased by 12.9%. Calculate how many members the federation had in 2016. And always remember the rules of thumb, right? Let's switch back to my laser pointer. Round percentages to one decimal place and use the same accuracy for new and old. We have a decrease here, right? So if I have a decrease, I start at 100%. 100 minus 12.9 is 87.1%, divided by 100, 0.871. This is my multiplication factor, and then I'm almost there. I just take the amount and do it times a multiplication factor, and now I round. Here the accuracy for old is in units, whole numbers, so here I round to whole numbers as well. Okay? And that's just a basic calculation for a percentage decrease. The number of members of the Dutch Boxing Federation decreased by 5.1% in 2015 compared to 2014. And then they started an advertising campaign, and the numbers increased with a whopping 45.4%. Now calculate the percentage change of the numbers. Watch what they ask here. They don't ask you anything about numbers. They just ask you the percentage change. So what you're going to do is work only with the percentages. I don't have to work with numbers here. Okay. So what I'm going to do is 5.1% decrease is going to be 0.949 as a multiplication number, right? 100 minus this, and then dividing by 100. A 100% a 45.4% increase. I start at 100% plus 45.4 divided by 100. So then this is my multiplication factor. And now to find the percentage change as a whole, I just multiply the multiplication factors. It's in the name actually, multiply multiplication factors. If you do this times this, you get an infinite decimal number. So here the percentage increase, because it's bigger than 1, is approximately 38.0%. Round this to one decimal place, round your percentages to one decimal place. You can find that by doing this times 100 and then minus 100, right? Again, you get 137.9, blah, blah, blah. Minus 100, you get 37.98, blah, blah, blah. Then you round 98, 8 rounds up, so 38.0. Okay? Practice this well, please. Good luck.